SQL injection is a method used, usually by a person with malicious intent, to retrieve more information than allowed from a database query. For example, when a user is asked to enter their username in order to find their account on a website. Database applications are susceptible to this type of attack when the application is designed using string concatenation in order to build SQL statements. In other words, an SQL statement, or a sentence designed to communicate with a database, is built piece by piece using information the developer has entered into the program and information that the user has entered into specific fields on the screen. Using this technique, a person would be able to retrieve all of the usernames and passwords stored in the database. The purpose of this video is to demonstrate the problems that exist with string concatenation for query building and the manner in which developers can use a method known as parameterization in order to defend against SQL injection with their database applications. The application we will be demonstrating is simple. The user chooses a method of SQL building and then enters the user ID that he or she would like the credentials displayed on the screen for. The application will be displayed on a virtual Android device emulating the Samsung Galaxy Nexus. It has been compiled for Android version 4.4 or KitKat and is backwards compatible up to Android's Gingerbread. To demonstrate the software, we will first be using the concatenation method of SQL statement building. First, we select the method of concatenations from the settings form. A method type is applied to a static variable in our main activity when the select button is pressed from our method selection form. If there is no value in the static variable, it will be notified via a message box on the screen and the application will close. After selecting the concatenate option, press the select button in order to save the preference to the application. Our app will bring us back to the main activity. The user is instructed to input the desired user ID by the text view control on the top of the display. First, we will enter the number 1. As you can see, the ID number, the username, and the user password is displayed on the screen. Now, to demonstrate SQL injection. Instead of entering a 1, we will enter a string that will always equate to true, such as 1 equals 1. To do this, we enter a number followed by a quotation mark to complete the statement intended by the developer. Once their statement is completed, we can continue with our own. We accomplish this by adding an OR clause to the statement and entering 1 equals 1 surrounded by quotations, but being sure to leave out the final quotation for the 1 on the right side of the equal sign. The reason for this is with string concatenation, the developer will have added this quotation for us. In doing so, the SQL statement will tell the database that all records should be returned because our modified SQL statement will always return the answer true, because 1 is always equal to 1, as you can see demonstrated on the screen. Next, we'll demonstrate another method of SQL injection. We will use commenting to change the SQL statement. Again, we start by finishing the SQL statement intended by the developer by typing 1 in the apostrophe. Then we add more to the statement. Here we will add another OR clause that states username not null, followed by 2 hyphens. This translates to the database that it should return all results where the user ID field is equal to 1 and all results where the username is not blank, which will be never in most cases. The 2 hyphens added after the null are the symbol for commenting in SQL query language, which means all the characters that the developer has added in the program source code to finish up with the query will be ignored, leaving only our modified statement to be evaluated. We can now see that demonstrated here. Again, we can see all usernames and passwords have been displayed on the screen. Now that we've seen the ways to use SQL injection, we can take a look at how to defend against it. Instead of building the string by concatenation, we'll fill the variable with the value entered into the box provided. We will fill the marg array with the string field entered by the user. The array is then used in the raw query method of the SQLite database instance. The difference is, here we are not simply stitching small strings together to make one large string. Instead, we're passing the sub-item of the argument array respective to the argument needed. Now, a user can still get a single description of credentials as expected. However, when one of the injection methods described earlier are used, we will see that the query returns no results. That was a small demonstration of SQL injection and methods used to defend against it. The language the project was written in was Java, using the Juno edition of Eclipse. The source code can be downloaded from the GitHub repository provided in the video description below. Thank you.